Today we will be factoring ax squared plus bx plus c, where we're factoring trinomials where area is greater than 1. This is very, very similar to yesterday's lesson of factoring x squared plus bx plus c. The only difference is, again, as a reminder, that a times c will equal the top number, and the number of x, which is plus b, will be your bottom number. We'll be, again, looking to split this into two numbers that multiply to equal the top and add to equal the bottom. And the only difference today is we're going to call this slide divide bottoms up, right? So once we break it down in our equation, right, we slid the a over to multiply by c. We've got the b down there. We split it up, so we divided it. And then bottoms up is what happens. We have to bring that a back. Both of these pieces will be divided by a, and then if it simplifies, we will simplify, right? So we'll see that in a real problem, but then when we're done, we'll have, right, something that looks like this and something that looks like this. And one of these numbers isn't going to be a nice number, so we'll slide the a by bringing the bottom up, and it will be ax plus a. But we'll see that in an example. But right now, that's probably too many variables for you to see and take in. When it does with the problem, you'll kind of get the pattern. So with these, we will be diamond problem. We're going to slide divide bottoms up, and that's what we're just kind of skipping through these steps. It's going to be slide divide bottoms up. All right, this is an alternate method. So slide divide bottoms up. And again, like last time, you can always check your answer by formula. I didn't do that in the video, but you can do it using whether you do the box method or FOIL. Okay, so in this case, we've got 3 times 6 is 18. And we have to add to equal 11. Now, just a quick note, this is where most of the mistakes are made. When people were getting used to yesterday's lesson of, oh, first we've got 6, add equal 11, right? This is where you have a big red flag. If you forget to multiply, there's no number such that multiplies equal 6 adds equal 11. That does not work. You need to multiply by the 3. It is that important. You will not find an answer without it, or at least a correct answer. Now, 18 is, right, 3 times 6, 2 times 9, oh, there it was, 2 times 9 multiplies to equal 11. Now, here's how the process goes. We now, right, differently from yesterday, we need to bring this 3 back into consideration. So what happens with this 3 is it's going to become the denominator for both 2/3, for 2 and for 9. So now I have 2/3 and 9/3. Which one of those can simplify? Almost every time, not exactly, but most of the time, we'll have to simplify. This one doesn't simplify on the left, so we're just going to call that x plus 2/3 just for now. It's not our final answer, but it's just a temporary part. Now, 9 divided by 3 is actually 3. That does simplify. I don't need this 3 over 1, but because that simplifies to 3, I'm just going to call that x plus 3. And if you look at that, it looks like we kind of have an answer there. However, we're missing something, right? X times x does not equal 3x squared. So here's where the bottoms up comes into play. Once we've kind of divided it using the diamond method and we've simplified, right, we now need to bring this denominator 3 need to come back up to next to the x. Right? What is the mathematical term for what we're doing? We're actually multiplying both of these pieces by 3. And that's going to shift that 3 from the denominator to next to the x. So instead of being x plus 2/3, we'll have 3x plus 2. Right? Because we multiply both pieces, we still have the same value. And this is actually our answer. Now, we're going to double check this one because it's so different. Right? How does that bottoms up not ruin our answer? How does bringing that denominator up not ruin? Well, remember, we started with a 3. So even though we kind of multiplied to get 18, we got 9 and 2, and then we divided by 3 on both sides. One side gave us a nice number on the right. Left side was still a fraction, so we just put it in the parentheses. And then we brought the 3 up next to the x to get 3x plus 2. So again, double checking. 3x times x is 3x squared. 3x times 3 plus 9x. 2 times x, 2x. Sorry, sloppy handwriting here. And 2 times 3 is 6. And so when I simplify, 3x squared plus 11x plus 6 should match my original, what we started with up here. And it's a match. So this was our answer. Next one, 8x squared plus 10x plus 3. 8 times 3 is 24. And numbers that add to equal 10 are, right, give me a second, 6 and 4. And now the 8 comes back down. Divide by 8, divide by 8. Now this is an interesting situation. None of those numbers look like they got any better, right? It's not 6 divided by 3 or 2. But we can simplify. This will become 3/4. And the right side will become 1/2. So now I'm going to write this as x plus 3/4 and x plus 1/2. Now again, not our final answer because we need the numbers in front to multiply to equal 8. And so now we're moving those, the 4 is going to shift to in front of the x, and the 2 is going to shift to be in front of its x to get 4x plus 3 and 2x plus 1. And there's our final answer. So that's where we brought the bottoms up. We slid the 3 over to multiply. Sorry, we slid the 8 over to multiply. We split it up using the diamond method. We divided by the 8 on both sides, and then we brought the denominator or the bottom number up next to the x to have slide, divide, bottoms up. So again, we're going to slide 3 times -5 to get -15. There's our slide step. We're going to have +2 on the bottom so that we use all 3 numbers. And now we're dividing this up, -15. Numbers that multiply are going to be 3 and 5. But how do we get 2, right? The bigger number is positive, so 5 minus 3 is 2. And now we're bringing the bottom back, so we're going to divide by 3. Right? Dividing was both the diamond method and bringing that a back into the picture. -3 over 3 is -1, so I got x minus 1. 5/3 is not so nice, so we're going to rewrite it and bring the denominator up, aka bottoms up, to get 3x plus 5 times x minus 1. We'll do 2 more of these after this one. 7 times 4 is 28. The numbers that multiply to equal -11. Right, we've got -14 and 2, and it's going to be -12. We've got -7 and -4. A little bit tricky sometimes, right? This one's positive, this one's negative. They both had to be negative, right? And so that's where the -7, -4, and now we're dividing by 7. So let me change my color for that. Dividing both pieces by 7. 7 over 7 is 1, and we got a negative. So x minus 1 is 1. X minus 4/7 is the other. And bringing the bottom up, we're going to get x minus 1 times 7x minus 4. Order, again, doesn't matter. Sometimes my x minus 1 will be in front. Maybe you get 7x minus 4 in front, x minus 1 in back. Now, the last 2 we'll do are right here. So try them out on your own, and then by pausing the video, and then check your answer. 9 times -4, -36, add equal -5. 9 minus 4 is 5, so it's going to be -9 plus 4. Bring back to divide by 9. So dividing both pieces by 9, I get x minus 1 and x plus 4/9. And then bottoms up. Bringing the 9 back up to get x minus 1, 9x plus 4. Second answer to check, 3 times -10 is -30, adds equal -x, which is -1. The numbers I get are -6 plus 5, and we're dividing by the 3 in front. That's where that 3 comes from. and minus 2 on the left, so x minus 2, 3/5 on the right. Now, if you want to do it this way, here's another way you can do it. Not very different, but I just sometimes push the number to the side, and then, oh, the 3 is going to come up. So I'll have 3x plus 5. You can minimize the number of times you're rewriting x minus 2. So that's up to you. But either way, just make sure you're showing the diamond method as part of your work. And somewhere in that diamond method, if we have an a value of 3, a 9, 4, 5, 2, etc., any number, show that you've divided and simplified where applicable.